Yes, welcome back to this session where we'll be again solving one numerical to clear or crystallize our concept of elevator angle required to trim an aircraft for a particular CL. We call it CL trim, and for various CG locations, right? Why this is important? You know that if I draw CM versus CL, and this is the variation of CM versus CL at equilibrium or at trim, it has a negative slope, that is dCm by dCl is less than 0, or dCm by d alpha less than 0. You know that both are equivalent because for dCm by d alpha, I can write it as dCm by dCl into dCl by d alpha, and this is CL alpha. This is always positive. So if dCm by dCl is less than 0, dCm by d alpha is also less than 0, and vice versa. So we will be writing, whenever we are writing CM versus CL variation, we talk about dCm by dCl is less than 0 for static stability, and when we are writing CM and alpha here, then we write dCm by d alpha less than 0. So both are equivalent statement, right? So now, if I see this variation, CM versus CL, what is this point? This point we call CL trim. CL trim. Why it is CL trim? Because this is at this CL, the aircraft is in equilibrium, right? Maybe one of the cruise conditions it could be. And also, you know, this slope of this line, which is dCm by dCl, is loosely given as xCg minus n naught bar. We have already derived that, which is nothing but minus static or stability margin. We have derived this. So we could see that this slope will depend upon xg location, right? Because n naught doesn't depend upon CG, n naught depends upon the configuration, right? It is the neutral point, a stick fixed neutral point. And how do we define neutral point? Neutral point is that CG location at which dCm by dCl equal to 0, or neutral point is that CG location at which the aircraft becomes neutrally stable. Or further, if I say, if I put the CG beyond neutral point, the aircraft will become statically unstable, right? So this is the concept behind what the problem will be doing. Also another concept we will check, we know delta trim or delta required is given by delta E naught plus d delta E by dCl trim into CL trim. And for approximate values, we have seen that d delta E by dCl trim, I can write it to be more precise for yourself, minus dCm by dCl, okay, divided by Cm delta E. What is Cm delta E? Cm delta E was elevator control power. What was the physics behind Cm delta E? Let us also revise here. This is the tail, this is the elevator, and elevator positive is down. So if I deflect the elevator down, there will be additional CL, so delta CL, and the aircraft CG is here. This will give me a nose down moment, nose down pitching moment, which is negative. That is why dCm by d delta E, that is pitching moment generated because of positive delta E is having negative sign. That is positive delta E will generate a negative pitching moment. So the sign of Cm delta E is negative, and this is also called the control power, more precisely elevator control power. Okay. Now with this understanding, we'll try to solve this problem. Let us read this problem carefully. It says for an aircraft, neutral point stick fixed is 0.5. Neutral point bar, that means what? N naught bar means it is neutral point location, non-dimensionalized with mean aerodynamic chord. It is 0.5. That means from the reference point, wherever you are measuring, the N naught is located as 50% of the chord, mean aerodynamic chord, right? Then SM is 0.3 or 30%, static margin is 30%. It means it is equal to 0.3 of mean aerodynamic chord, the absolute value, okay? The absolute value, the separation between neutral point and the CG This distance is 0.3 C in absolute sense, right? So that is the static margin. Then CL trim is 0.6. So if I draw it like this, try to draw this problem, this is CM and this is CL. What does it say? It says that CL trim is given as 0.6, 0.6. So I mark here, this is 0.6. And what further it says? It says, when I have made the CL trim, when I have trimmed the airplane at that CL, I did not require any elevator deflection. That means whole of this CM naught was generated otherwise from tail setting or from aerodynamic center ahead of wing. So aerodynamic center of the wing ahead of CG of the airplane. So point is, elevator deflection was not given. It was not required. But the aircraft could easily trim at 0.6. So this is delta E. Elevator deflection is 0. Then what further says? He said when he was trying to trim at CL equal to 0.4, then he required a elevator deflection of 4 degree. This is degree. 4 degree downward. And you know, as per the convention, elevator deflection down is positive. Okay? So this is delta E. Delta E is for CL 4.4. When it's trimming, it required a delta E equal to 4 degree or 4 degree down. Okay? This question clear? First is when the aircraft was trimmed at CL equal to 0.6, we didn't require any delta E 0, but for the same configuration, nothing has changed. No CG has changed, nothing has changed. Same aircraft when we were trying to trim at 0.4, then delta E required was 4 degree down. Okay? So that is the understanding. Okay? And what is the question? Question is calculate elevator control power. That is, calculate elevator control power. By now you are smart, and that is nothing but Cm delta E. Okay? And second is, if new CG is 0.4 C bar, then what is the CL trim? The aircraft can be trimmed with delta equal to 0. So second question is, if the CG of the airplane changes now, and I change it to 0.4 C, then what is the CL trim that I can trim the airplane, but I will still not give any delta E 0. So second question will come in elaborate way. First let me complete elevator control power. Okay? So we know CL trim equal to 0.4, that time delta E equal to 4 degree, then CL trim equal to 0.6, that time delta E equal to 0 degree. And what is the relation I know? D delta E trim equal to delta E naught plus D delta E by DCL trim into CL trim. Okay. What is our aim? Our aim is to find Cm delta E. Don't forget this. Where is Cm delta E lying in this expression? Let us look into this. Is there any Cm delta E in delta E naught? Let us check. Yes. Delta E naught is nothing but minus Cm naught by Cm delta E. Do you think Cm delta E is here? Let us check. D delta E by DCL trim is also minus DCm by DCL by Cm delta E. So indeed it is also here. But what are the information I have got? You could see that CL trim 0.4, CL trim 0.6, and corresponding delta E's are given. That means I have been supplied with D delta E by DCL trim as how much? D delta E by DCL trim is 4 minus 0 by 0.4 minus 0.6. D delta E by DCL trim is nothing but, what is the D delta E? Delta E is changed from 4 degree to 0, so 4 minus 0 here. What is the change in CL trim? It is, when it was 4, it was 0.4 was CL trim, When it was 0 degree, it was 0.6 was CL trim. So if I find it out, I find this is equal to 4 by minus 0.2, and this value is nothing but minus 20 degree. Let me write like this, 20 degree. Correct? 4 by 0.2 is 40 by 2 is minus 20. So this is the information I got. D delta E by D CL trim is equal to minus 20 degree. Why 20 degree? You could see this is 4 degree, 0 degree. That is why, and this is non-dimensional. CL has no dimension. So this is actually 20 degree. Unit is degree, minus 20 degrees. Very, very important. You must not lose sight of this, what you call their units. Okay. Now once you know this, what is our aim? Our aim is to find Cm delta E. That is the aim. Okay. So let us go for the next step. I know D delta E by DCL trim equal to minus DCM by DCL by Cm delta E. This I know now, which is minus 20. Because D delta E by DCL trim already have calculated to be minus 20. So now check here. What is our aim? Our aim is to find Cm delta E. Now the question is, do I know the value of DCM by DCL? See the data here. What does it say? N naught SM, static margin. What is static margin? You know, DCM by DCL, we have derived that, equal to minus static margin, which is basically minus N naught minus XCG. Okay? Right? I put a bar because non-dimensional. I know that now from the data, DCM by DCL equal to minus 0.3. As simple as that. So the problem is solved. What is the solution now? It is straightforward. Let me erase this. So I have got minus 20, and here DCM by DCL is minus 0.3. So I put this number here, 0.3 minus 0.3 by Cm delta E equal to minus 20. So Cm delta E is equal to 0.3 by 20 minus sign. So this is minus 0.015. You should do it per degree. I'm underlining this. The unit is per degree because this 20 was in degrees. Okay, and this is 0.3. Clear? So you could see that if I have got this minimal information, I can easily find out what is the elevator control power. Okay? Now the second part we'll attack. The second question, let us check here. If new CG is 0.4 C, that is new CG location is 40% of the mean aerodynamic chord, what will be the CL trim for delta E equal to 0, right? That is the question we are going to ask. That is, now new CG location means the DCM by DCL, whatever was earlier given, is no more valid because now CG has changed. Okay, a new CG. So CG has changed, static margin will change. So now the question is, it is given now XCG is equal to 0.4 C bar. This point I want to find out what is that CL trim given is delta E equal to 0 again. So now the question is, what is this CL trim value? Right? Okay? So this is CL trim, this is delta E. If I increase this, this is delta E naught. We will make one assumption here. Ideally, if you see what is delta E naught, delta E naught is minus Cm naught by Cm delta E. So if the CG is changed, then see from here, this is the wing, this is the tail, this is the CG of the airplane. From here to AC of the tail is the LT. And all those moments, Cm delta E, will depend upon LT. Now we have changed the CG. So the Cm delta E ideally will change. But we are assuming that this change in Cg is not affecting the value of Cm delta E or Cm naught. Please understand this is an assumption, and practically it is true also, right? The variation will not be large. But this problem, we are constraining that although that Cg has changed, that will change Lt. We are assuming that Cm delta E, Cm naught are same. So what is the assumption? We understand that Cg has changed, so Lt will change, and that will affect the value of Cm delta E and Cm naught to some extent, because Cm delta E we know is proportional to the tail moment arm. But in this problem, we are assuming not affected. These two derivatives are not affected. This is the assumption, which is not very unrealistic. Okay. So if I do that, then now I come back here and I try to find out what is that CL trim. I can trim the airplane for a new CG location, which is 0.4 C, but I want to keep that delta E 0. So what is our aim now? Our aim is to find out what is that CL trim for a new CG location, but we want to keep delta E equal to 0. So let us solve this problem. So I write it down. XCG is 0.4. Okay. CL trim, I want to find out what, but I know delta E I have to keep 0, that is delta E trim I have to keep 0. Okay. So now, what is delta E? Delta E equal to delta E naught plus d delta E by dCl trim into CL trim. Okay. So what is delta E naught value? So this is, since we have assumed that with change in LT, this Cm delta E, Cm naught are not affected, so I can easily find delta E naught from the first graph, where this was 0.6, delta E was equal to 0. So this is basically delta E naught, and this delta E naught by geometry could find that, and since this slope is d delta E by dCl trim is minus 0.3, that was given from the first case. So I can easily find out that this delta E naught value is 0.18. That is 0.6 into 0.3. That is, it will be this delta E naught. Okay, from triangle you can find out. This I am able to get from the first condition, first problem here, because I am assuming that Cm delta E and Cm naught are not changing. Okay, so I know delta E naught, so I put here delta E naught value, which is known. What about d delta E by dCl trim? Because we have to find out this. Now d delta E by dCl trim, let us see what is happening to that. So d delta E by dCl trim is equal to minus dCm by dCl by Cm delta E. But we know that in the second case, the Cg has changed. So dCm by dCl is no more I can use the earlier dCm by dCl. Clear? Because we have only assumed that because of change in Cg, Cm delta E and Cm naught are not changed. With the change in Cg, dCm by dCl will definitely change in a drastic manner, because we know dCm by dCl is nothing but minus of x naught, that is neutral point, minus xCg. Okay? That is why we say if xCg coincides with neutral point, then you say this is neutrally stable, that dCm by dCl becomes 0. Right? So we have to take this into account, that as Cg has changed, dCm by dCl also will change. But the question is, do you know the value of neutral point, stick fixed x naught? Do you have any idea? What is the value of that? What is neutral point? Let us ask ourselves. Now we are trying to find out what is dCm by dCl for new CG location. CG location. That is what? That is XCG equal to 0.4 as in the second case. There, XCG 0.4 C bar, right? We need to find out what is DCM by DCL for new CG configuration, and you know DCM by DCL is basically XCG minus X neutral point, and you could see here the neutral point is given as 0.5, and you know the neutral point is not going to change because it depends upon the configuration, wing configuration, tail configuration, engine configuration, the speed, everything is remaining same. Neutral point will not also change whether you have changed CG here and there. So I will keep this as minus 0.5 as the first case, and this case it is 0.4. I put it bar because they are non-dimensional. So now I could see DCM by DCL is coming to be minus 0.1 or 10% of mean aerodynamic chord. That separation. The slope is minus 0.1, right? So DCM by DCL is negative, so it is statically stable. That means whatever new CG is there, we should be ahead of neutral point, and you could see that neutral point is at 0.5 and new CG is at 0.4. So yes, it is ahead of neutral point. So DCM by DCL is negative, and indeed it is coming like that. Okay. So now I know DCM by DCL and what is the value of DCM by DCL. Okay. So DCM by DCL is minus 0.1, and we know that we are working with relationship delta E equal to delta E naught plus minus DCM by DCL by CM delta E into CL trim. We want to find out what is the CL trim so that delta E is 0, and we also know delta E naught equal to what? Delta E naught equal to what? We know delta E naught equal to minus CM naught by CM delta E, and if you recall from the first case, this is CM versus CL, where this is 0.6 given, and the slope is minus 0.3 as given in the first case. So this CM naught value from this geometry, it is 0.3 into 0.6, this is equal to 0.18. Right? From the first case, I could get the value of CM naught. And since I am been telling repeatedly, because of change in CG, there are no changes in CM naught or CM delta E as we have assumed. So I will use this CM naught value. Okay? So we'll use this value, and what is our aim? Our aim is to find delta E naught. If I know the value of delta E naught, then I can easily use this relationship, because this I know, I have to find this. So if I know this, then I can easily find this. So delta E naught will be what? Delta E naught is minus CM naught by CM delta E, and you know the value will be minus 0.18 by 0.015 minus. So this will give me around 12 degree. So delta E naught, please note down, this is again 12 degree because CM delta E is per degree. Okay, we have already found it out from the first problem. Right, from here we have already found it out what is the elevator control power, and that happened to be minus 0.015 per degree. So delta E naught is 12 degree. Now what is the problem? Everything we know now. So what I have to do? I have to simply use this relationship and find out what is the CL trim required. So delta E equal to delta E naught plus minus DCM by DCL by CM delta E into CL trim. Delta E naught is 12, this is 0. Now everything we know, we have to just use the relationship, and in this you know delta E naught is 12. What is DCM by DCL? DCM by DCL is nothing but XCG minus n naught or x n naught, and this is 0.4 minus 0.5. So this is minus 0.1. This value I can put it here. Cm delta A I know 0.015 minus, this is 12 degree. So I can easily calculate CL trim by inverting it. So CL trim I will get around 1.8. So see, through this relationship, how we have calculated different requirement of delta E for different CG location, right? So I hope if you solve this problem yourself, you will get the hang of it and how to use this relationship for your practical problem. That's exactly why I am repeatedly supplying you so many problems so that you can crystallize all the concept. Okay? Thank you very much.